And you always reduce fractions. So that means that you always reduce ratios. Okay, so we're thinking fractions when we're thinking ratios. Sometimes they can look a little different, and we'll get to another notation in just a second. Here's the information for our first example. A class has 8 girls and 10 boys. Okay, there are several different ratio questions that I can ask you regarding these 8 girls and 10 boys. Okay, the first ratio question is if we need to write the ratio of boys to girls. So we're comparing the number of boys to girls. So we're going to write it as a fraction. What number goes in the numerator of our fraction? Boys
numerator
to girls. So
8 boys.
10
girls.
boys to 8 girls. It does matter which goes in the numerator and which goes in the denominator. If it said girls to boys, we'd have a different number. So this is 10 to 8, but it can be reduced. It can be reduced to 5 over 4. Now, if you're not good at reducing fractions, you can always use your calculator, 10 divided by 8, and then change it to a fraction with your math frac button that we've done before. Okay? So, 5 to 4. You can also write a ratio like this, 5 dot dot 4. That's the other way of writing this ratio. I'll accept either. Most of the time you'll write a fraction.
Isn't there another way to write it? 5, 2, 4.
5, 2, 4 with the word 2. Yeah. We'll just leave it like this for now. So girls to boys, that will look differently. What goes in the numerator for this one? 8. Same numbers, 8 to 10. Girls to boys, 8 to 10. So then we reduce that fraction, 4 to 5. 4 girls to every 5 boys. Again, dot dot is not meant to be 4 dot. So 4 to 5. Same information, we could ask the ratio of the number of boys to total students. So the number of boys is 10, and 18 is our total students. So sometimes you have to do a little bit of math in this problem to figure it out. 10 to 18, so that would reduce to 5 out of 9. And we could say every 5 out of 9 students is a boy. We could say every 4 students, for every 4 girls, there's 5 boys. So the sentences would sound a little bit different depending on what the original question says. Okay, so the ratio of boys to total, 10 to 18, so it reduces to 5 ninths. Okay, sorry, that's just a blank slide. All right, sometimes when we want to reduce units have to be changed in order to reduce this should say ratio. Okay, so sometimes units must be changed in order to reduce a ratio. Right here I just have some things. They should be common to just about everybody besides Harry and Grace because they weren't raised on the English system. These are metric. This looks real familiar. Okay, 100 centimeters to 1 meter. That'll be harder for those of us who aren't as used to metric. 1,000 grams to 1 kilogram. But for Harry and Grace's benefit, 12 inches equals 1 foot. And 16 ounces equals 1 pound. When you see in the homework, you may see converting pounds to ounces, or inches to feet, or feet to inches. So these are the ones that you'll need for this homework. Okay, 12 inches is 1 foot, 100 centimeters is 1 meter, 1,000 grams is 1 kilogram, and 16 ounces is 1 pound. Okay, so what do I mean by that? We want, your direction would say rewrite so the numerator and denominator have the same units, then reduce. So here's a nice ratio. Okay, 20 centimeters to 2 meters. Do they have the same units? No. But in order to make this ratio reduce, we have to click them so that they have the same units. Okay, so it's always easier to go from a bigger unit to a smaller unit. Which is bigger, meters or centimeters? Meters. It's always easier to go up than it is to go down. In other words, there are more centimeters, that's what I mean by going up, than it is to go down. So we're going to leave our 20 centimeters alone. And how do I change 2 meters into centimeters?
Bring it over, wouldn't that be 10?
How many centimeters are in 1 meter? 100. Just right up here, I have reminded you 100 centimeters in 1 meter. So in 2 meters, shouldn't there be more? Yeah? So 200, right. You're going to multiply times 100. And that gives you 200. So 2 meters is 200 centimeters. Okay? 2 meters is 200 centimeters. It says rewrite so they have the same units. Now we have the same units.
Is that a 2 or a 1? Oh, 2.
This is a 1, this is a 2. Yes.
So what about the numerator? Just move it over?
The numerator is, we want them to be the same units. So if I'm converting the denominator to centimeters, this one can get left alone because they have to match. Okay, they need to match if it tells you to make them match. Okay, so now 20 over 200 reduces to 110. The units have canceled, so 1/10 is our answer. So they have to have the same units first and then reduce. So that's one thing that you can do with ratios.
Could you just divide that and make 10 and then add the 1? Or just
No, you can't because this one just happens to work that way because it's 100, but it may not work this way. Like if this was with grams and kilograms, you have 1,000, you'd get something completely different. And it doesn't just flip the numerator and denominator. It happened to look that way on this one, but that doesn't just happen. You have to actually do the work, convert one of them so it matches the other, and then reduce. All right, let me give you another example here. 2 feet and 27 inches. 2 feet to 27 inches. Now, which is smaller, feet or inches?
Inches.
Inches are smaller, so in this case, we want to make feet into inches. So, how many inches are in 1 foot?
12.
12. We had that on that little reminder that I just wrote for you. So that means for each foot, we have 12 inches. So I need to do 2 times 12. And so 24 inches is 2 feet, 27 inches here, and then we can reduce. What goes into numerator and denominator? 3. So this is 8 over 9. Okay, so this one's a little more obvious, Imani, as far as not just being able to divide and then flip it. That just was a coincidence in that other problem. All right, so you convert to the smaller units and then reduce. Okay, whichever one is the smaller unit, leave that one alone. All right, everybody have that? Okay, we're going to move right along. This is proportional. If 2 ratios are equal, they're called proportional. Okay, and a proportion looks like this. One fraction equals another fraction. Fraction equals another fraction. On SATs or standardized tests, you might encounter this notation. I say might, I don't know if they're still using it or not. I don't prefer it. I like the fraction ones better. But notice this means A over B, this means C over D, and then this set of dots means it equals. So this really means A is to B like C is to D, or A is to B as C is to D. and that's what those dots are really meaning. But like I say, I much prefer the fractions and the equals, and that's what we're going to emphasize. But I want you to see that. Shouldn't it say what? A proportion looks like this is a proportion. Question, Alexis? Oh, right here? Good. Okay, so I'll let you say that one. We're looking for what's missing here. These are equivalent fractions, came from eons ago when you learned these things, Alexis. What does go in the question mark goes? 6. How'd you get that?
5 goes with 15 3 times, so you multiply 2 times 3.
Good. So she remembered that this is times 3, so if you multiply numerator times 3, you have to multiply both numerator and denominator times 3, so that gives you 6. Okay, so these two are proportional. 2/5 is proportional to 6/15. Yes.
Can you cross multiply these?
That's next.
Oh.
Yeah. Absolutely, yeah. If we're going to solve them, in general, usually we'll end up using cross multiply, but I need to teach you the cross product property, which you probably already know. We use it a lot, and the reciprocal property, which we're going to mention, but we're not going to use as much.
Reciprocal.
Cross product property says that if A over B equals C over D, then cross products are equal also. AD equals what? BC. Okay, so AD equals BC. Cross product property. We use that to solve a lot of the problems where we have fractions being equal to each other. The reciprocal property says if A over B equals C over D, what are reciprocals?
B over C.
Yeah, B over
B over A is equal to
D over C. Flip them. Yep, that's it. So that's our reciprocal property. This one's more useful. Cross products we're going to use more to do problems. We can use this one. It's just harder to find a place where you can. Okay. All right. So we've got these two properties that we're going to use heavily in order, well, the first one, in order to find answers to questions. Alright, so solving using proportions. This one's not as obvious as far as finding something you can multiply times 1. So this is where the cross products comes in. So 4 times 7 cross this way is 28 equals 5x. Divide both sides by 5. So x equals 28/5. You can give an answer as an improper fraction, or 5 3/5 as a mixed number, or 5.6. I'm going to prefer the fractions. However, if the decimal ends, you can go ahead and give the decimal. Okay? Like if you had 5.333333, just write that with 5 1/3.
Wait a minute, what is it? 5.6, isn't that 6 repeating?
No, 6 repeating is not the same as 5.6.
No,
6
I mean,
repeating is 2/3. 3/5 is just
Oh, yeah.
0.6. So they're two different numbers. You're not the only one to ask. Someone asked in the morning class too. This is an ending decimal. 66666666666666666. On and on and on. That's a repeating decimal, and they're different fractions. Okay. All right. Let's see if we can get this one in. Once again, cross multiply. So we bring this around, and we get 3y. We bring this around,
2y times 3.
and we get 2 times y plus 2. So don't forget to distribute there. 3y equals 2y plus 4. And then subtract 2y. So y equals 4. Okay, so that's a nice little problem to do. Antonia?
Will we just find Y or X, whichever case, or will we put it in the problem itself?
It would depend on what the question asked. Usually, like this one would say find, we'll give it a direction, find Y.
Okay.
Okay, then you know what you're asked to find. If they ask what would the proportion be, then you could plug it in and do that, but this is just find Y. All right, I think I'll probably need about 10 minutes when we get back, but regarding word problems and geometry, proportions can be used to solve word problems as well as find the dimensions in similar geometric figures. If we remember from the very first chapter, similar means that they're the exact same size, the exact same shape, either blown up or shrunk down, so that they are proportional. We used that word proportional in the first chapter, but now we can actually use it in a little bit better. Okay, yes. Okay. Let's read this. Let's get this written in your notes first. Ratio of the width to the length of a swimming pool is 3 to 5. You'll frequently see the dot notation, the ratio notation in something like this. So width to length is 3 to 5. So out of those two numbers, which goes with width? 3, and which goes with length? 5. So it doesn't actually mean that it's 3 inches, 3 feet, 3 miles. It just means this is the ratio of the width to the length. And then the second part, if the actual width is 20, find the length. So we are going to use a proportion to do that. Okay, Alexis, how will I set up my proportion? 3 over 5. And just before I write the next part, remember this is the width and the length. The width over the length equals
20 over x.
20 over x or L or whatever your variable needs to be. I'm going to use an L just because it says length, but you can use whatever you want. 20 is the width. I'm glad that you got that correct. The width of the swimming pool is 20. So here's the width part. 3 to 5, 20 to unknown. Right, exactly. And after that we cross multiply. So we have 3L equals 100. So L equals, it's 33 1/3, or 100 over 3, 33 1/3. What's my unit? Feet. So if the swimming pool is 20 feet, it's going to be by 33 1/3 feet. Now, that's not too terribly large of a swimming pool, but it's not teeny tiny either. So 3 to 5 helps you figure out the ratio of the actual answer. So you set it up, and then you can do the problem using proportions. That's a little bit like we did a little bit in chapter 1, but now you're going to be made a little bit more responsible for it. Okay. Oh, wait. Okay. Sorry.
Sorry, sorry.
That's all right.
What's that say? 33? What?
33 1/3. Fix that.
Okay.
Look at it. There you go. 33 1/3. So it works also if you have pictures. You can find a missing piece in a geometric figure. Okay. As long as the figures are similar. Okay, there's that word coming back that we briefly discussed in chapter 1. They're similar figures, so this one is an exact blow up of this one. Okay, this is a 4. Okay. So we have an X and a 9 on this one, and a 14 and a 24 on this one. So we need to set up a proportion. You have to put up something goes with something, like something goes with something. So we have a fraction. Alexis, what do you want to be in the one side of the fraction?
X over 9.
Okay, so X goes with 9, They're actually in the same figure. X goes with 9. Think of this equals as a like.
And 14 with
14 goes with 24.
Does it matter if they're switched like 9 with X and then 24 with 14?
Okay, because you switched both, no, it doesn't matter. So, 24, yeah. Okay, so if you put X over 9, you have to put 14 on the numerator over here. Because you've got this side actually goes with this side. So the two sides that are the same piece of that shape have to be in the same location. But if you put 9 over X, then you'd have 24 is the part which goes with 9, so the 24 would be in the numerator, and that's fine. That's where our property that we had, the reciprocal property, comes in. If you flip these two over, as long as you flip both, it's still the same thing. Okay? So let's multiply this out. This is 24 equals, what's 24x equals 126. So this is 126 over 24. So we can reduce that. That's what, 63 over 12. Did I get that right? 63 over 12,
Yeah, that's not right.
which reduces to, if we divide those both by
3.
3,
We're gonna get 12.
21 over 4.
21 over 4. Okay,
Yeah,
so sometimes
that's
you
what I
can
got.
reduce a couple times. 21 fourths. You can leave it as an improper fraction, or you can make it mixed. Only make it a decimal if the decimal ends.
Like it's 5.25 again.
It's okay, but just make sure that you can do either or. Okay, so this one, 21 fourths in its completely reduced form, or 5 1/4, or 5.25. Okay, and that gives you enough to do all the assignments for number 44. 44 is due Monday. If we have snow on Monday, you are responsible for watching, and then 45 will be due on Tuesday. If we have snow that lasts Monday and Tuesday, then you're responsible for going online each day and seeing what the new information is. Because, like I say, SAP, College Board doesn't care that we had snow days that we didn't make up. So we need to make sure that you all have the education that someone that loves you will send you to get. So we're going to turn off this.
No one loves me.
Nobody loves you, that's sad.
Oh, dang.
That is really sad.